Welcome guys to this, I hope is going to be a short video about solving trig equations. So today in class we, briefly I suppose, looked at how to solve equations of this type. We're after one solution. So I'll just do one further example of this with you, and then we'll have a look at the purpose of this video, which is to look at how to find sometimes exact solutions where they're not decimal approximations but they're multiples of pi. So for this particular one here, our steps to solve this one would first of all be to move that 20 to the other side. So what I'm going to do is take that positive 20 over this other side and become minus 20. So 40 minus 20 will give 20. Then we can get rid of that negative 25 from that left hand side. Let's move that over. We end up with 20 divided by negative 25. Of course that could be a simplified fraction, but we're going to be doing most of the work on the calculator and get a decimal answer, so I'm just going to leave it like that. Next we need to use the inverse sine function. So we're going to take the inverse sine of this 20 over negative 25, and then finally, to get x on its own, we're going to find this value, and then I'm going to add pi over 4, moving the negative pi over 4 to the other side, becoming positive pi over 4. Now plugging that into your calculator, should give a value of negative 0.142. Let's say we're rounding here to 3 decimal places. Okay, now a lot of trig equations have these sort of approximate answers where we're needing to round. Now there are some where there are exact solutions. So let's have a look at some where we can find an exact solution. And how would we know? Well, what we're going to see is that sometimes solutions come out to be multiples of either pi over 3, pi over 6, pi over 4, or maybe on a very rare occasion pi over 2. Now in degrees term these would be 180 degrees, pi over 3 would be equal to 60 degrees, 30 degrees, 45 degrees and 90 degrees. And they actually match up with a couple of the two special triangles that we have met before. And let me just draw that very approximately here. Okay, so we've got our right angle triangle there. Let's say that this here is an angle of pi over 3, and this one pi over 6, and you might recall that the sides are 1, 2, root 3. And then the other special triangle has those pi over 4 angles in them. So approximately, let's draw it like that. So this is 1, 1 square root 2, and these angles here pi over 4 and pi over 4. Now they also, of course, you could put these in degrees rather than multiples of pi. And in fact, when I'm going to be doing my working, I'm in fact going to be looking for solutions which are either these ones here as part of our working, or multiples of these. And I think the best way to explain that is with an example. Okay, so let's take a look at this particular example. So we've got the cosine of x plus pi over 4 equals a half, and we're asked to find an exact solution. So in other words, one exact solution. Now to do that, I need to take the inverse cosine of 1/2 here, and then we're going to then add pi over 4, sorry, subtract pi over 4 from that. So when we do that, when you take the point where you take the inverse cosine of 1/2, what I'm going to do is I'm going to actually just temporarily do that in degrees. So my working might or will look like this. And the reason I prefer to do this calculation here in degrees is that I find it easier to well, recognize these things as multiples of 180. So if we take the inverse cosine of 1/2 and just temporarily put the calculator into degrees mode. So just bear with me while I'm doing my calculator work here, changing my calculator to degrees mode. So inverse cosine of 0.5, that was 60 degrees. Now 60 degrees, okay, that's pi over 3 radians. If I had on my calculator put inverse cosine of 0.5 and my calculator was still working in radians, let me just put that back for a moment, inverse cosine of 0.5, I get 1.0471975551. I don't easily recognise that that is equal to that, pi over 3 radians. So this is why I'm going to do this in degrees for a moment and say, alright, that's this comes out to 60 degrees, which is equivalent to pi over 3 radians. So I'm going to put this now in radians term. But it was easier, as I say, to recognise that is equal to this, rather than trying to have a decimal value for this and trying to convert that. So instead of having 1.0471, etc., recognising that that is somehow pi over 3 radians. A bit difficult. This is easier. Okay, having got to here, we're now going to subtract pi over, take from pi over 3, subtract pi over 4, and we do not do that with some plug it into the calculator. We do a bit of fraction work here. So I'm going to put them both over 12. It becomes 4 pi minus 3 pi equal to pi over 12 radians. And this is an example of an exact solution. Okay, a fraction of pi or a multiple of pi. Okay, let's do one further example. Okay, so let's take a further example here. Let's maybe do one of the sine function ones. So let's take 2 sine of x is equal to root 2. Okay, first step would be, let's get rid of that 2. So we get root 2 over 2. Now we could take the inverse sine of that, or you might recognise that that is going to be 1 over root 2. Why? Because we get root 2 and the 2 is the same as root 2 squared. Cancel root 2 top and bottom, and we end up with 1 over root 2. Just as an aside. Now on my calculator, once again making sure that I'm working at the moment in degrees mode for this. Okay, the inverse inverse sine of 1 over root 2. Okay, I get 45 degrees. And 45 degrees is equal to pi over 4 radians. So we get x is equal to the inverse sine 1 over root 2. Okay, and that comes out to 45 degrees or pi over 4 radians. And we want to express the answer as a fraction of pi. And that is our solution. Okay, let's do, I think, just one more. And since we've done a sine and we've done a cosine one, let's do a tangent one, just for fun. Right, so tan of x over 2 equal to negative root 3. Okay, once again, inverse tan of negative root 3. Calculator again, so inverse tan negative root 3. Okay, that came out to negative 60 degrees. Okay, which is the same as negative pi over 3 radians then. Okay, so x equal to 2 is equal to negative pi over 3. X would equal negative pi over 3 times 2. And we get negative 2 pi over 3 radians is one exact solution. Okay, well there you go guys, that's it for now. Okay, and we will do some questions on this in class tomorrow. If you're wanting some further explanation of this, have a look at page 14 of your workbook. Just bear in mind that they do the working in a slightly different way. They don't do this, get the answer in degrees and convert to radians. I actually prefer strongly this method. I find it a lot easier to do. Now guys, we'll catch you gentlemen tomorrow.